So question 8, June 2021, it says Marla buys two types of mobile phones, B Flow and the C Flex, from a company for retail, and it says one B Flow phone costs $60, one C Flex costs $80, and she buys X number of B Flow phones and Y number of C Flex. Part A1 says Marla must not spend more than 1,200, and they want us to write an inequality to represent this information. So we know that B Flow, just writing out information, B Flow is $60 and C Flex is $80. And she buys X number of B Flow phones, so it would be 60X, and Y number of C Flex phones, so it would be 80Y, and they're telling us that it must not cost more than 1,200. So we're dealing with inequality, so therefore it must be less than or equal to 1,200. And this is what our inequality will look like. So we have our B. Yeah.
Sir, when it have the arrow got it. Yeah, when it have the line underneath it, sir, that means less than
or equal to no. So if it didn't have the line beneath it, it would just be less than. But when this line is underneath it, it is saying less than or equal to. Good.
So when the line underneath, it means greater than.
If the line was turned the other way, so this sign right here is less than or equal to. If it turned the other way, this is greater than or equal to, which is different from this sign, which is greater than.
Sir,
So yes.
it said the 60X plus the 80Y should not be more than the 1,200. You would have turned the arrow the next way, point it to the.
No, but that's what the question said. The question said they must not.
Come here, say serve as an example.
No, but no, you would only turn it if they had said that she can spend more than the 1,200. But the question said she must not spend. So expect that whatever this is, 60X plus 80Y, it must be less than 1,200 or equal to 1,200. But it must not be more than 1,000. If it can be more than now, it would have been 60X plus 80Y. The sign would have been the other way to say greater than 1,200. If it was a case where she could spend more than the 1,200. Right? And the good thing is, math again, we know that this can be simplified. We can divide through by 20. We can say 20 into 60X. That will leave us with 3X plus 20 into 80Y. That is 4Y is less than or equal to 1,200 divided by 20. That will leave us with 60. And this is our simplified equation and our answer. And it's a 1 mark question, guys. So there's no if or but as to what it is. Part 2 now says the number of B Flow phones must be greater than or equal to the number of C Flex phones. Write down an inequality in terms of X and Y to show this information. So all it says, B Flow, which is X, greater, so X, and they said it is greater than or equal to, so this now CJ is how that sign looks, greater than or equal to the number of C Flex phone, which is Y. So this is our inequality. Another 1 mark. So B flow is greater than or equal to C flex. And that is our 1 mark. Part 2 now, they says represent the two inequalities on the grid below and label as R the region which satisfies both inequalities. Now the region R would be where both shaded region from your graph is overlapping. So now let us pull back our inequalities. Our first inequality was the was the 3x plus 4y are the same 60. Anyone you choose to use the 60x plus 80y is equal to 1200. So what we're going to do is to check in both instances what would be our x or y value when either one is 0. So for example, we can say, what is our y value when x is 0? When x is 0, you would get 60 times x, 60 times 0 to give us 0. So what you'd have is 80y is equal to 1200. And therefore, y is equal to 1200 divided by 80. So 1200. And when you do that, what do you get? When you do 1200 divided by 80? $15. So therefore, when x is 0, y is 15. So that's one of our first point that we can plot. So when x is 0, y is 15. Now, so this is our first point, x is 0, y is 15. Now we can look at when y is 0. So when y is 0, what we'll have is 60x is equal to 1200. So therefore, x is equal to 1200 divided by 60. What would that be? $20. So therefore, what we're saying then is when x is 20, y is 0. So this would be our second coordinate. And remember, when you're plotting graphs, especially straight lines, all you need are just 2 points on your graph. So when x is 20, y is 0. So we can now join these two lines. All right, that is very lean. Can I? So that is our line. And basically, remember, this is when it is equal to, otherwise it must be less than. So therefore, this is the shaded region on our graph for this one. This is our shaded region. Now, the other inequality was x is greater than y. So we're looking for the line at the point at which x is equal to y, because it is x is greater than or equal to y. So we're going to plot when x is equal to y, which means that that line will be passing through the line of origin, if we remember. So it will be passing through this point, because when x is 0, y is 0, when x is 1, y is 1, when x is 2, y is 2, when x is 3, y is 3. So that will be this line here. And it will be beneath it that we are shading. So when you shade beneath this one at when, these are the points at which x is greater than y. And as you realize where you overlap, where both graphs overlap, that is where the part that satisfies both inequalities. And they said we should label it as R. So all we need to do is to just put a big R right here, because this is the part where both inequalities overlap. And what we usually do is to label our lines. So this is where x is equal to y, and this is the 60x plus 80y is equal to 1,200. And this is your answer. Part 4 now says the total number of mobile phones is represented by x plus y. According to the graph, what is the largest number of x plus y? So when you're looking at this, we are now going to be looking at the areas that satisfy, oh sorry, Arian, go ahead.
Sir, how come you use the end of the graph as a border?
Go again. We use the end of the graph as a border.
Yeah, so I use x equals 0 as the border for those two.
Either way that you choose, your points on the line will pass through that. But if you realize what we did when we got those is using this first equation, where it says we're just looking for 2 possible points. So what I usually do to be as accurate as possible is to use 2 of the furthest points on your graph, and that is usually when x is equal to 0, what would be the corresponding y value, and when y is equal to 0, what would be the corresponding x value. And that is what we did here. And you'll now see what makes those values important, because now for part 4, where they asked us to tell what is the largest possible value of x plus y, what you're using to determine that are the vertices on the area which satisfy both inequalities. So you're looking at here, what is the total number of phones there, what is the total here, and what is the total here, because these are the 3 vertices where the inequality was satisfied. We know it can't definitely be here. This can be the largest possible value, because right here everything is 0. But for right here, this is somewhere between, so this is 5, 6, 7. So this is about 7.8 plus, let's say 8. So that would give us, that's what, 15.8 phones. So probably round it off to 16 phones. So at this point, they're telling us that the complete of the x plus y is 16, rough estimate, not accurate figures here. But for right here, we have 20 and 0. So the largest possible value of x plus y is 20, and that is when the x is 20 and our y is 0. So you're always, when they ask you for the largest possible value, in this case, using the graph, you're looking at the vertices of the areas of the inequality that satisfies the graph there. So where they overlap basically. So you're looking for the vertices in that portion. So we identify the 3 vertices, looking at the compilation of all of the x plus y coordinate from those vertices. What would the total be? In this case, this one here would have given us the total, which is 20 plus 0, which should have given us 20, and is the largest possible value of x plus y. So let me just write that down in terms of notes. So we're saying comparing the vertices, the highest number of phones is 20, and that would be when x is equal to 20 and y is equal to 0. So therefore, highest number is 20. Any questions from that? All right. So part B now, they gave us a table and they want, as I said, on the grid provided, plot the remaining 4 points and draw the graph of this function. So they didn't plot the last 4 points, which would therefore mean it is these points here. So they want us to plot these. So it is 0, -4. So it was 0, -4. So which means that's a 0 from our x-axis, -4 from our y. The next one was 1, -2, so 1 from our x-axis, -2 from our y, and 2, 2, so 2 from our x-axis, 2 from our y-axis, and 3, 8, so 3 from our x-axis, 8 from our y-axis. Just going back up to show you the points. That is what was there. So it is 0, -4, then 1, -2, then 2, 2, and then 3, 8. And they want us to plot the remaining points and draw the graph. So we're now going to draw our best fit line through these points. And remember, when we reach here, which in this case would be a minimum, we should have a little dip. So we're going through our points here. Yours would be much straighter than mine, but this is what your graph should look like when you join all your points. So they said we should join our points, so draw our graph. So this is what we'll do, and you get your full 3 marks. So first, we finish plotting our graph using the 4 missing points that were given. Then we draw our graph. Part 2 now says, write down the maximum or the minimum value of the function. So using our graph, we can use our graph to get those, or you can work it out using the formula, but a graph is given, So why not choose the easier way out? Looking at this graph, what would be our maximum? What would be our maximum or minimum value? By the way, is it maximum or minimum? I did state it earlier. Is it a maximum or a minimum? Very good, minimum. So what are the minimum value for this function? Anybody, what is the minimum value for the function?
So -4.
No. So as you realize, if you put -4, I am assuming they will give you incorrect, because if you realize, remember when you're drawing your quadratic, remember there's always a dip. So if you realize my line isn't on -4, and by the way, -4 is the y-axis, you also need the x-axis, which would be the axis of symmetry, which is the line that splits your graph in two. But if you write -4, what you're telling me is that we move from this point and just go straight across. When that isn't the case, there's usually that little dip, which is what is shown here before it starts going back up. So what is our x-axis there and our y-axis?
Sir, -4.
Tony, is -3 is it the x value or the y value? Because I'm just wondering. Because we
Sir,
thought
-4.1 and -0.5.
So you're telling me that -4.1 is the x value? That's what you're telling me, CJ?
Yeah.
CJ, you're telling me that the x value is 4.1? I could swear I've been teaching that when we're writing coordinates, we write our x value first, and our x value is definitely not 4.
Oh, sorry.
Yeah, go in an exam and write 4 first and see. But yes, so one thing I see is consistent. Indeed, or x value, which is our axis of symmetry, is -0.5, which is -0.5, which you guys have been saying. So indeed, the value for the minimum will have -0.5 or -0.5, and let's see. So 2, yeah, that's what I'm more so getting towards, Tony. I'm more so getting a -4.2. For a -4.1, your answer will still, more than likely, you'll still get it correctly, because they will have a range of numbers. But if you write 4, you will not get it correctly. That's one thing I'm sure of. You will not get it for 4. But if you write -4.1, -4.2, the exact answer though is -4.25, -4.3. Any one of those in that range, you will get it. If you write -4 though, you will not get it correct. But 4.1, 4.2, 4.3, you will get the answer. So that is our values for the minimum value. I think I'm too far. Minimum value for our quadratic graph there. Now, part 3 says, using a ruler, draw the axis of symmetry. Now, once you know the minimum value, you can also easily tell what the axis of symmetry is, because the axis of symmetry is the x value from your minimum value, which is also the line that splits your graph in two, which would be this. So all you're doing is just drawing this line on your graph, which is at the -0.5, which you identified, or the -0.5.
Sir, what the formula for find axis of symmetry again?
X is equal to -b over 2a. So that is the formula if you ever need it in an exam. x is equal to minus b over 2a.
You know, have a formula to find minimum value or that?
Same formula. Remember, the formula is just used to find the axis of symmetry. So that formula is the axis of symmetry formula, Tony. So let's say, so we get the axis of symmetry, or minimum value for x is 0.5. You can put this, so if we should employ that formula, so remember, a here would be 1, b would be a positive 1, c is negative 4. So our x then is equal to minus b, and we get b to be 1, so minus 1 over 2 multiplied by a, and our a also is 1. So therefore, our axis of symmetry is negative 1 over 2 ones, 2. So you realize that we get back the same half. So let's say you were working a question where a graph wasn't given, because that has been done before. A graph wasn't given, and you get your function, and they ask you to find the axis of symmetry or the minimum value for your function. This is the formula that you would have used to solve for that question, which is x is equal to minus b divided by 2a. So from your function, remember this function is written in the form of ax squared plus bx plus c, which is your quadratic formula, quadratic expression there. So a, in this case, there's nothing attached to the x squared, so a is 1, or b is 1 as well because there's nothing attached to the x, and our c would have been negative 4. C isn't important here because the formula is x is equal to minus b over 2a. So use that formula, and it have given you the corresponding x value, which is also your minimum value on your graph, or your maximum value. So that is what that formula is used for. Follow me, Tony? Good. Now, let's say they ask you, or they ask us just now to find the minimum value for the function. You now found the x value. You can now input this number into your formula, into your function, to get what the corresponding y value is, which is b from the y-axis. So if we have negative a half square, so you have negative, so following from the function here, negative a half square plus a negative a half minus 4. So let's see, negative 0.5 square, negative a half square, you will get let's see, negative a half squared, you'd get a quarter plus well, this would be minus a half minus 4. When you put that in your calculator, a quarter minus a half minus 4, you'll get, this will be equal to, our calculator give us negative 4 and a quarter. And that is how I know that the answer down below, the exact answer is negative 4.25, because I put it in the formula. And that's why I'm saying to you, they will accept a negative 4.1 and negative 4.2. Negative 4.25 is the perfect answer. If you put negative 4.3 as well, you will get it. But if you put negative 4, your answer would be incorrect. So you're seeing here how we use both the axis of symmetry formula and the function that was given to find the corresponding minimum values for our function.